Okay, so now we're going to look at this circuit and the differential mode voltage. Now again, we're really looking at a DC analysis still here. We aren't getting into the small signal yet here. We will of course get to that here. Once we do the differential mode voltage, we'll go through an example of computing some of these parameters here. Okay, so first off, we have these VB1 and VB2 here, and let me just emphasize here, this is still Q1, Q2. Now what we're going to apply here is we're going to apply not the differential voltage, but we're going to apply the differential voltage divided by 2. And then we're going to apply the negative of the differential voltage divided by 2. Now remember here, my differential voltage was defined as VC1 minus VC2. Now if I look at that here, this of course is VC1 and this of course is VC2. So if I do that computation, you get VD over 2 minus negative VD over 2, which is just VD. So we do get that. Now, sometimes you have to be careful. Some authors choose to do it slightly different, and I'll show you what some authors choose to do with their voltage supply, is they write that as VD over 2, but then they flip the power supply to be minus plus, which of course is just the exact same way. I don't know why. I just get in the habit of doing it like that and putting a negative on it. Different schools of thought on it, but that's just the way I tend to do it. Alright, so now what we have to do is we're going to first just make an assumption here that that this increase, that VD over 2 is only a few millivolts. And the reason we're going to do that is so that we can apply just some delta I's and delta VBEs and things like that. Okay. But with that, we know first off, that VB1 does not equal VB2. And since VE1 still has to equal VE2 because they're tied together, right? The emitters here are literally tied together, so they have to be equal still. Then VBE1 no longer equals VBE2. But we also have a thing here. We know VB is greater than VB1, I should say, is greater than VB2. How do I know? Well, that's a positive number. That's a negative number. So this means VBE1 is greater than VBE2. So IC1 will increase by some delta I. I don't know what that is. I'm just going to say some delta I for now. But since these voltages are the same, I should say since the magnitude is the same, we know IC2 will decrease by delta I. In other words, what we have here is that VC1 is equal to V plus minus, well, it's going to be ICQ over 2, or IQ over 2, that's what we've been doing, plus delta I times RC. Because it's still going to be, you know, this is VC1 here. So all I've done here is said that, okay, well, if I look at this current here, IC1, that's increased, and it's increased by delta I. And what are we saying? Well, when we went back to the common mode one, that's where they had the same voltages. When they had the same voltage on there, we said that, well, IC1 is just equal to IQ over 2. IQ over 2. And then VC1 is just V plus minus IQ over 2 times RC. Well, now we're saying, okay, well, it's increasing from what it was in the common mode, but it's increasing because we're doing it just by a few millivolts. It's increasing by delta I. So this current here is really equal to IQ over 2 plus my delta I. And then similarly, we would get that VC2 is equal to V plus minus, and this time it would be IQ over 2, but now I'm decreasing the current times RC. And then we get VC2 minus VC1 here. Well, let's just do the subtraction here, see if we can do this here. Well, actually, let's just be careful here. So we'd have V plus minus IQ over 2 minus delta I RC minus V plus minus IQ over 2 plus delta I RC. Well, clearly these V pluses are going to cancel, right? And then I'd have a negative IQ over 2 RC plus delta I RC, so that's distributing the negative and multiplying by R. Now we have to be careful here. Negative, negative. So that's going to be plus IQ over 2 RC plus delta I RC. And so, again, canceling these terms, we get that VC2 minus VC1 is equal to 2 delta I RC. So in other words, we have a voltage difference that we've created when we have a difference in the voltages on the inputs, which, I mean, really shouldn't be too surprising, but the key thing here is this difference on the output is, I mean, it's kind of hidden in here because we have this delta I business going on, but it's directly by whatever this voltage VC1 and VC2 are. Alright, so in the next video here we're going to look at an example that goes through this.